This video is continuation to my previous topic on prediction. Regression can be used as a prediction, right? So in this one, we are going to study about using this data. The same data is there in the Excel and Minitab also as well. And we are going to take a look. And there are 6 topics we are going to cover. One is the variable, and among this one, so there are 3 variables we have, and one is a response. So which variable to consider, and this is categorical value. So for example, these two is insignificant, not significant, and all that. And then we are going to do that analyze ToolPak, where we are going to do without applying any formula, we can directly get this one directly from analyze ToolPak, and we are going to compare in Minitab. So first in Minitab, sorry, in Excel, we can do one by one. For example, salary is my response. I'm going to compare with the publication and then salary and then years. And let's see whether gender has any influence on the salary. That also we're going to study. And then a residual plot is very important. Residual is basically an error. And whether the error is so significant or not, we are going to study. So both from Analyst ToolPak and Minitab. StatGuide has given bit more detail. We are going to talk about those 4 chart in detail. Some chart like histogram versus fit, residual versus order we are going to study. And then we are also going to study that probability plot also as well. And then prediction, as I said, this is the main core of the discussion, prediction and response optimizer. We're going to say if we need, let's say this is 88, this is in K, right? If I want 1 lakh, how much experience I should have on the publication side and the overall side. We're going to study that also as well. And then response optimizer, also we are going to study and then interpret the overall result. Response optimizer is also been widely in the in design of experiment we use, but in the response we can use it for the variable that is on regression also as well. Interpret the overall result as we go along. We time to time we're going to study the Excel formula, and then charts also we are going to study. So this video is going to be a bit longer. If you want, you can just the increase the one, and for example if you want like 1.2 or 1.3 speed, you can keep it, right? So stay tuned, but it's going to be very very detailed and useful discussion we are going to have. Okay, so let me pick this one from Minitab. First I wanted to find out Minitab older version, very older version I have, called Minitab 17. I want to find out which variable to consider, which variable is not considered. For example, if the male and female is not having any contributions on the salary, then I have to neglect it, right? So first we can do, and what I'm going to do is that directly it is there. Go to stat, and then you can go to regression, and here you might find the same example also, multi-regressions. So okay, this is the different data set, but however we can go back and find something else, right? So this is also another example, and but I do remember that the example of, sorry, I do remember that file name. So we can pick from here, open worksheet, look at Minitab data folder, and then research is that one, research salary. So this is the same data which I have in Excel also as well. The same, both are pretty much same data. Basically, I've taken from Minitab and have pasted in Excel as such. Okay, let's get started. First, what I am interested is that which factor I need to consider. And for example, the gender does not have any influence, right? We can just remove that variable. If publication doesn't have anything, we can remove. So salary is there in 1000 and 88,000, 77.3 and so on. And gender, male and female, publication, how much year. So that means 11 year, in which publication in that site is 4.5, right? So this is how it is there. This shows that overall experience zone. So let's get started. So first what I'm doing it, I'm just finding out the regression, and then I'm just going for multi-regression. So therefore I went to regression. Response is my salary, and then continuous data. I'm going to pick publication. and year as well. The category I have is male and female, so I'm gonna keep it here. Okay. Okay, so now this has given this detail. Degree of freedom is 3, and year. So if you say that year has a significant impact, right? So that means year is important. In order to get more salary, year is playing a more major role. And year and publication and year, I mean publication experience and year is having more one, but gender doesn't seems to have any significant role. Why? Because the alpha, it is greater than the critical value, so it is greater than 0.05. So 0.05 we refer to that. If you go for 95 percentage confident, and 0.05 is considered to be the allowable limit, right? So, but it is going beyond that 28.3. So I have to investigate. So what I will do, only this one very super quickly I will do that ANOVA. So what I'm doing it is that, so response is the salary and factor is the gender. I just wanted to double check, right? So for example, male is getting the salary, overall salary. This includes everything. And I'm not dividing it by the year and all that. I'm just simply saying whether the salary these two are impact. And with that, what I'm doing it, I'm going to go to this one. And again, it is the individual if you study with all this 1.0, 6.3, still it shows not significant. So I'm not really going to bother about that. So that means I'm not going to take in that my in equation. So what I will do, I'll go to stat and I will go to regression. In the regression, here it gives me the prediction, but before that, what I will do, best subset, for example, let's say, again, I can do the same thing, which is my best subset. I can ask Minitab to do it. For example, let's say the response is the salary, free predictor, let's say publication is a free predictor, and then yes, right? And all that, I mean, just give, okay. So if you look at here, how to read this one, best subset is that if you take this one, the highest R square value. The highest R square value is that R square adjusted is the one which I'm going to consider. And this is 88.8. And then you have that the other, this should be the highest and this should be the lowest, right? And if you take this one, both the variable, and one variable is called publication, one variable is the years, right? So both seems to have that very impactful. In this case, both are playing a role. So therefore, confidently, I can go for these two. One is year, one is publication. Okay. So with that, what I'm going to do, I'm going to do that regression. In the regression, I'm going to do that the again this one, but only thing is I'm going to exclude gender because I have already studied that ANUVA. Through ANUVA, I got to know that gender is not impacted. Okay, okay. So my model has become better, 89.44, and then this is significant because the p-value is 0, significant, and then I have that error. And this salary, this is the equation it has given, and then residual, every detail it has given. Okay, and then we can also do that prediction also as well. So let me complete Minitab part first, and then we can compare. We can come back and compare. Right? So predict. And let's say I need individual value. Let's say I have that the 5-year experience and total experience is 10 year. Then another one is that I have 2.5-year experience or 2 year or 2.5 I can put, and then experience is 5, right? And then I'm just saying I have 5-year experience, but here only 7-year experience I have. So let's see what is the predicted value for salary. So let's start with the 3 scenario we have given. So it is going to give me 3 scenarios. So 5, considering that publication experience is 5 and 10. So I'm going to get that the salary between 79 to 82 as a confidence interval, and predicted value is 71 to 90. Somewhere in that range, I'm going to get it. And if this one is low, the experience is low, the salary is also getting low, right? 67,000. And somewhere between 57 is a predicted value, between 57 to 76. And then this one, out of 7 year experience, largely I'm in the same publication experience. This is going to make an impact, right? So although the same 5 year, if you take it to overall, but the same I have spent on publication, so that means 76,000, and then somewhere between 66 to 85 in confidence interval it goes by 74 to 77, right? This is how I can easily get it. So if you want further detail, like how to find out and all that, so you have here, right, the same model we are talking about. This pharmaceutical company wants to model the relation between salaries of research scientists with the gender, year of experience, and then index of publication of quality, right? So all that it is given. So therefore, we can find out the same example which we did it. Okay, so this is the one. And then let's say this is one way. Going back to regression, the regression I'm gonna go. Let's say this is predict I have done, and then factorial, what is impactful and all that I can put it. So contour plot also can do all the other things being open. So one of the widely known is that response optimizer, and salary should be high, right? So maximize I will give. Yeah, okay. So in order to get the maximum salary beyond a lakh, right? 108K beyond 1 lakh salary, that means 21 year experience, and publication should be 8.8. Let's say I can also change this model also as well. Let's say I have 10-year experience, okay, and publication is this one, that may 89. So let's say this also I'm reducing it. Maybe I will put like 583, right? So I can easily see that one. So this is how we can get this one, the same value. Let's say exactly I can give like, let's say 5, and I'm gonna give this also 5, right? I can also directly input also as well. So that means 72. Right? So these two are intersecting. This two is a good line, right? So we have learned in the design of experiment what is meant interaction 0, interaction 1, interaction 2, and 3. So if you want further guidance, you can click from here. This is what I was talking about. The interactions and all that we have already studied as part of the design of experiment we have studied. Now we are not going to do that, but this is how we can predict that model, everything, right? And also same like design of experiment, you can also get the overall value also as well. Let's say if you want like the overlaid contour plot is an example, right? So I'm going to select salary, and so y-axis I'm going to keep it like publication in year, right? With respect to sorry, y is my output, right? So one second. So let's say low and high. I need to define it somewhere. I need 75 to 100, 100K. Okay, 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 okay. So it gives that in order to get the salary between these one, so I should have that 10-year experience, and as an overall, out of which I can have that minimum of publication 3 years and all that, right? As it goes up, the salary also goes up, everything, right? So this is also very interesting chart. And then you also have similarly, you can get the other one also as well. Not many things you can do. Contour plot is also you can give, for example. So as the experience goes up, right, up and up, you get more and more, right? So in the beginning, 5 to 5 this year experience, you get this one. As it goes up, so the salary is getting higher, so it shows dark green, right? So this is how we can easily interpret. Now I'm just coming back. So what I will do, I will take only salary as well as publication. I'll do it in, now I'm just converting from multi-regression to single regression, right? Example, so that I can show you in Minitab also, I mean Excel also. So what I do, I just go to that regression. In the regression, I'm just now clicking that best fit example, and I'll remove this also as well. So I just, here also as well. And one thing which we forgotten is that residual plot, right? So graph 4 in 1. So it gives all the residual 4 residual plots. So we can give that. Okay. We'll discuss this one in detail when we go and discuss from the Excel. So this is the one, and gives a degree of freedom is 2. That means 2 minus 1. And publication, only we are studying about publication, and then error. And we'll talk about this error 87.05 adjusted mean square and all that. and then pure fit and how much error is there this model has got, and the moderate correlation, right? This is moderate. The same thing what I will do, and now I will study the years, right? Total year, and go back to session folder. Session folder. So this is very important. So that means, so from the R square, what we understand is that there are two. So salary, for salary, three factor we studied. One is that gender. Gender doesn't have any influence. So male and female has no big difference. Okay. So we remove that model, and then we learn publication. I mean, in that particular experience, and then we also learn the overall experience. So overall experience looks to be 83 percentage, that is greater than 70% is strong correlation. But here we saw moderate correlation. So what I will do, I will perform only the correlation for the, since it is greater than 1, and if you look at here in the previous one, we have seen that the R square value is 53, example here 53. So that means a moderate correlation, and this is 1. But when it comes to the significance level, these both are significant. That's the reason you have to check the p-value as well as R square value. Both you have to check. So now I'm clear. So this I'm going to remove. And so these two, among these two variables, this is the most significant factor. These two are significant factor, of which R square is also good and the p-value also good. Here p-value is good, but R square value is not good. So we are going to take this. Okay. So with that, let's come back here, and R square and then p-value also very, very good. So let's do that in Excel. So in the Excel, so we have done this one. So first one variable to consider, and we are going to consider, we're going to exclude the gender, short answer. And which variable? So what is significant? Year or total year is more significant. Why? Because there is two things. One is the R square value is good, as well as p value is good, small p. Significance, right? Both statistic probability of significance is good. And then we have studied this both the one, but we learned that this is found to be good. And then now we are going to do that residual plot, analysis ToolPak, and all that. I will come back and study and explain the Minitab how to find it out, that also as well. So let's go back to residual plot. So first, let's do that. Now what I'm going to do it is that I'm going to, just for the simplicity, I'm going to delete this data, and this data also I'm going to delete, and for few columns I will keep it here. Okay. All right, so let's get started. So now what I will do, I'll just perform. So very simple. So if you wanted to do that in the, I mean, Excel, you can directly do it here. Like you will give that graph, and this graph, if you go to design and tap on quick layout 9, it will give you the one, but default mini Excel will do with the linear. But if you want, you can change also as well, 83.26, right? The same thing we have also got 83.26, the same value we have got, and then y equal to mx plus c, right? So you also got the similar equation, 60.7 and 6, skipping it here. Okay, this is for year, right? So yeah, salary versus, yes. So you also got that equation. So we'll talk about that equation in a bit, right? So this one 0.38, and here we have differently, because we have here we have seen in the here we have done that best fit, and here we have done that as a individual regression as well. So but okay, but R square value is important for us, so now it is okay. So this is the how we can easily do it here. I'll keep it here. Okay. So now I will go to data, and in the data I will go to analyze, data analysis, regression. I will click on it, and then in the regression, let me show you this one. Input y is the output, that is salary. So what I will do, I will just clear here, take this up. Okay. So this is done, and then x, I'm gonna do the same one. same something like that. Similarly, I'm going to do it here also as well. So labels labels I have not given, so I don't have any zero also as well. So confidence in 95, I'm going to keep it somewhere here, example, maybe here. Okay. And then I need the residual plots and all that. This is something which we can do it later, but I'll just give everything. Okay. Okay, so it has given a lot of charts. That chart we are going to discuss about it. Excel hasn't given good chart, but we can say percentile and variable chart, and then you have a versus plot, everything. So we'll come back to this charts later. Just keep it here. Okay, so now let's see the summary. So multi-regression, so it is given that the 91, but R square 1, it is 83, right? 83.25. We've already seen that. Adjusted is some values been adjusted. This how to find that one that in the previous video we talked about it. Adjusted R square is always less than R square. So anyways, it is since it is greater than since it is greater than zero point 0.7 is considered to be strong. So what I will do, I will just keep it here. Since greater than zero point 0.7, we will say it is strong correlation. Meaning, so it is salary has an impact on yes. Otherwise, weak or we can say weak or uh, moderate or the weak correlation, right? It depends on the data, but I'm just keeping it here just to give you that perspective. Okay, so strong correlation. So if this value would have been like 0.08, then 0.08 is the weak correlation, right? And now we got the good model here, right? So then a standard error is actually like so there is two formula. One formula is STEYX, and then it will ask for Y. So this is the Y we have, and then the X we have. So exactly the same thing, right? So we can easily find out the standard error. So how you typically calculate the standard error of mean? So this is the standard error that we get that line, right? So the same standard error also you get it here, 5.5. So then observation. So if you take this one we're talking about, and with 35, 35 is observation, and if you minus 1, it becomes 34, the degree of freedom. And then you get the sum square, mean square, and from there f value get calculated. If you divide, and then significant value, everything get calculated. And then we are talking about intercept. It is intercept value is that y equal to mx, right? 60, right? 60.7, right? This is what we are talking about. And the standard error has got this error 1.97, and then it goes all that, right? Upper value and all that. So now it also has given the residual plot. Residual is basically an error, and it has given that what is the observation. It has counted all the value, 35 values we have, and then predicted value. Predicted value, so it is each data point it is predicted. So you can also do it here, for example. Say just deleting here also. This also okay. Here oral experience I'm keeping it, so I'll delete this also here. So okay, predict how we can do stat, and the same value you will get it here also as well. Let's go to regression, and then here you have a predict, right? In the predict, so from salary, what you are going to predict. So each column, so here, so we are going to predict this model, correct? Yeah. So and then if this is the input, here is the next input. So you get all these value 84 point this one. So the same thing 84.5 and 73 and so on so forth, everything you get it. And then I will come back to this later. This is predicted value, and then you have a error, everything, and confidence one, everything is there. So I'll delete this for now. Okay, now, so this is we call it a predicted value, right? I'll rename it. And then what is a residual is actually residual is nothing but from the actual value, that is actual value minus the predicted value is the residual value, the balance, residue, right? Balance. So how you do? So for example, you go to calculator. Same thing, Excel has given that one. So let me prove that how it is Excel has done that. So this is the value. This is our response. We already know that response has an influence on here. And this is predicted value. I'm assigning this formula. For example, 3.4, 3.5, right? So exactly the same value you have got 3.4 and 3.5. And then standard the residual. The standard residual is being influenced with this value. We can easily get to know that also as well. And then you have a percentile. So all the percentile value. So this value has been there. For example, 1.4 percentile is 58, and then 5 percentile and on, right? So until 100, and all that is being distributed in the percentile fashion, right? So now, if I use this here, almost you will get the. Let me show you that how the residual plots is calculated. Okay, 50.1. Okay, so I need one more column. Maybe I'll keep the column. Probability plot also you have. Okay, there you go. So let's see that the first. Let's start with this one. Let's go back, and here we can. So let me go back to this, and sorry, here we have done. Is this the data for salary? And maybe let me do it one more time. Okay, maybe I will use a fitted one. Both are same. So here is the salary is the year. Linear let it be, and then I'll ask for the fit 4 in 1. Okay. All right. So let's see that one. So this value is pretty much scatter versus plot, right? So the value is between 10K, right? Around 10K minus and here, right? The error. So the same thing you can get it here also. You do it here. I mean, this is we are getting this chart, right? Versus other, right? So between 5 to all, it's exactly the same thing, right? If you look at here 3.4, here you have 3.4 and all that, right? So 3.4 is here, and then it goes on and on, right? So we can just format this one. Let's say the maximum you need only 30, 35 maybe example. Okay, almost the similar one we have got with respect to zero line. So we got this also as well. This is one chart. The fourth chart, this is called versus plot. This is called versus plot. Residual versus plot, right? Okay, this is done. Okay, and then pretty much scatter, right? So this is good. Histogram, the same thing, you can get it. So you can get that histogram also. Pretty much like probability plot, right? So you get this one on the first chart, right? Like probability plot. And this also we are getting it, right? So this is also nice chart we have got it. And further, if you wanted to improvise, of course, you can do through the design, and you will get that equations, everything, right? So this also you can get it. So I will keep it here. Okay. So what is the next thing to do? Let's come back to this one. Okay, residual and this one predicted. And now I want to see that this salary and predicted whether they are going close by or not, right? I can just check that up. So this is going very close. The predicted and this one is very very close, right? And so why these too many values are there? I will delete this one, but I will get an idea that these two are going very close also as well. This is also good, right? And if you want to have that formatting everything, you can just do that also as well. Okay, but I'll just close this one. And then you have that residue standard one, right? The standard, that is also we can do. Okay, so this also you can get it, right? So like the scatter one, this is the first, second chart, right? So the standard fit, residual versus fit, right? So between it, this one, it has been will scatter and the value is not too far away and all that. So if you want, again, you can just keep it up to 35. Only formatting you need to do. So it's pretty much scatter value. This is good. And then histogram, you can do the same thing. The same one, you can do the histogram also as well. To do that histogram, again, you have to calculate that histogram value, everything that I'm not going to do it. In a previous video, I have talked about it. Like this, you can do. For example, if you want both the chart like this, that you get the nice chart, right? And if you want the percentile, the nice chart will come up for you, right? Very nice one. Like this, it goes linear and all. So like this, you can easily find it out. So this topic also we have done now. Okay, let's go back. So prediction we have done, response optimization we have done, how to interpret we have seen, and some of the Excel formula we have seen, chart also we have seen, and this is how we can easily get to know the one. I hope you find this detailed video useful. Please do like, share, subscribe my channel. You have a wonderful day.